Here is a question on general organic chemistry. Read the question carefully and think about the answer. Let us solve it step by step. Let us first understand the key concept here. Alpha hydrogens are hydrogens on carbon atoms directly adjacent, alpha, to an aromatic ring, or in the context of carbonyl chemistry, adjacent to C is equal to O. Here, alpha hydrogens refer to CH bonds on sp3 carbons that are directly bonded to the aromatic ring. The compound shown is a polycyclic structure with a central aromatic ring, shown with a circle, fused to 3 saturated, cyclohexane type rings. This is consistent with a structure like 1, 2, 6, 7, 8, 8A hexahydro as indacene or a similar tricyclic compound, essentially an aromatic ring with 3 saturated rings fused around it. Moving on to the next step. Identify the aromatic ring. The central ring with the circle is aromatic, benzene type. Moving on to the next step. Identify the alpha carbons. Alpha carbons are the sp3 carbons directly attached to the aromatic ring. Each saturated ring that is fused to the aromatic ring contributes carbons at the fusion points and adjacent positions. And for the final step, count the alpha CH2 groups. In the structure shown, 3 saturated rings are fused to the central aromatic ring. The carbons at the ring junctions shared between the aromatic ring and each saturated ring are the alpha carbons. However, the shared, bridgehead, carbons between the aromatic ring and the saturated rings are themselves part of the aromatic system. They bear no H in many fused systems. The CH2 groups immediately adjacent to these fusion carbons within the saturated rings are the alpha carbons. For this specific structure, which appears to be acinaphtylene with an extra ring or a fluoranthene partial structure, examining the saturated rings, each saturated ring fused to the aromatic nucleus contributes CH2 groups alpha to the ring. Based on the structure, there are 3 CH2 groups, each with 2 H, that are alpha to the aromatic ring, giving 3 times 2 equals 6 alpha hydrogens. Why not other options? Option A, 4 and B, 5 undercount the CH2 groups adjacent to the aromatic ring. Option D, 7 is not possible since alpha carbons occur in CH2 pairs, even number, or specific CH positions, and 6 is the correct count from the 3 pairs of alpha CH2 groups. Therefore, the correct answer is C. Therefore, the correct answer is option C.